Okay, so this is a recording for case bundle number 3's first reading called Mastering the Three Worlds of Information Technology. So it talks about the fact that there are several kinds of technologies or several kinds of IT technologies that any organization needs to master if they want to actually succeed in their respective specific industries. So in the information era, computer hardware has been changing, and it keeps on changing and keeps on improving as per the Moore's law, which means that technology or hardware and computer systems become twice as fast within 18 to 24 months and about half the price, which means that you have to decide whether or not to acquire these new technologies. If you lag behind, you will lose out on getting those technologies. So we need to bother about it. We've also discussed in earlier readings that having IT technologies doesn't give you a strategic advantage anymore unless it's proprietary technology. It is actually a commodity. However, technology cannot be ignored because it is also essential for your very existence. Therefore, you need to come up with a middle ground where you will get technologies or infrastructural technologies or IT technologies or IT resources to actually get your job done without thinking of them as strategic resources. Anyways, so for that you need to build an effective IT model. So you need to understand that when you're building an IT model, you need to understand why you'll be using those technologies, how you'll be using them. They've discussed another theory called the cycles of building in management research. That's a paper by two authors. One of them is the Harvard Business School professor Clayton Christensen, who also talked about disruptive innovation theory. So they talk about how you need to have the right kind of technologies in place. So he's given an example. It says that a good theory in his article, he talks about the fact that a good theory groups important phenomena into categories, and within those categories it makes statements of cause and effect. So when we're looking at our theory that we build right now, we need to keep this in mind. So this article specifically talks about three categories of IT and divides it, and that's a very nice table given here, into three of these categories. The first one is functional IT or function IT, the second is network IT, the third is enterprise IT. Now, of course, like any theory or any framework, it's helped to make you understand what is happening in the industry. This does not mean that this is the only way to look at IT technology. We saw earlier that we divided them into two kinds of technologies. One was proprietary, the other was infrastructural. This is another way of categorizing it. So according to this article, IT that changes the way that we work, that it changes the way that we do our stuff, can be divided into three categories, namely functional IT, network, and enterprise. So let's look at each one. Functional IT or function IT as it's called is IT that actually helps you with executing your specific tasks. And when I mean specific tasks, I mean more operational tasks, things that are needed to be done on a day-to-day basis, things that are needed to be done for the organization to actually move along. So the definition that's given in the article is IT that assists with the execution of discrete tasks. And when we say discrete, we mean measurable, specific, or very operational level tasks. It gives another angle to it by telling us about its characteristics. It says it can be adopted without complements, which means it can be done on its own. It doesn't need to be associated or connected with any other tasks. This function IT helps us do things that are in themselves complete tasks. They're not part of some other tasks. And the second characteristic is impact increases when complements are in place. So if you were to do function IT tasks, or you are able to achieve function IT level information technology and do some things with it, and you've got some other tasks also being done, those two tasks together may be complementary as well. So there are some examples: simulator software, spreadsheets like Excel, or computer-aided design like AutoCAD, statistical software like SPSS, Jamovi, JASP, R, several others. So whenever you are resorting to or working on things which are of an operational nature, what you're dealing with is known as the function IT category. The second one is network IT, and as the definition puts it up, the name is easy enough to help you understand, and as the definition says, it is IT that facilitates interaction without specifying their parameters. In short, technologies, and when I say technology, I automatically mean software, hardware, and protocols that go with it, and the procedures that go with it. So it says that it is basically a kind of a set of technologies that lets you send and receive and communicate and interconnect systems and send and receive data. So it doesn't impose any complements, but lets them emerge over time, which means that it doesn't force itself to work with other systems, but because of its very existence, you will see that you will gain complements. When I say complement, I mean when different IT categories working together give you more advantage than when they would if they were working in isolation. So network IT helps you create more, as you would say, network effects out of those technologies being used. So it doesn't specify any task or sequences. These kind of technologies are not about doing your operational work. They are about connecting what you're doing at an operational level. So it accepts data in many formats. So it's open to several formats because the entire purpose is to communicate and intercommunicate and interconnect systems. And the use of these technologies is optional. Now, I would disagree with this part. In this day and age, no organization can survive without having network IT. This may have been the case that they were optional back in the earlier days, not anymore. So the example given here is the simplest one and probably the most important one is email. One would think email, that's not even that important. It is. Emails are known as the killer app of the century. Okay, that's the most important technological creation that we did that uses networks in the last 100 years. So instant messaging and wikis are pages that are written, which are crowdsourced. Like Wikipedia is an example of wiki pages where people actually contribute information. So you could have wiki pages for an organization where everybody contributes to it and helps the other employees learn from it. It's kind of like a knowledge management system of sorts. Blogs, we all know what blogs are. Everybody writes them, whether they be in video format or in text written type format or with images or infographics. Blogs are also examples of this. Mashups, which are a combination of all of these. So, and most importantly, which is missing here, but probably mentioned somewhere else in the document, is collaboration software. Microsoft Teams, Google Meet, Slack, which is another software, Zoom. All of these pieces of software are designed to help organizations and people working in those organizations communicate with each other and share what they're creating using function IT. So all the tasks that they do at the function IT level is shared and connected and communicated and collaborated over using network IT. Then we have the third category of tasks, which is enterprise IT. Now, as the name suggests, this is more about things that connect the organization with its various components. Now, a lot of students, a lot of people confuse this with network IT. Yes, they're interlinked. You cannot have an enterprise IT without having strong network, which is why I said that I disagree with the point which says use is optional. It's not. So, enterprise IT, it is the IT that specifies business processes. If you recall, if you remember, when I said that ERPs are not about technological change, they are about business process change, because ERPs are designed based on the best practices of their respective industries. Every module that is created that is part of an ERP is made using the best practices of that industry for that particular business process. Hence, when an organization implements ERPs, what they're essentially doing is implementing the best business practices and business processes in their organization. So the whole point of an enterprise IT software, therefore, is to specify a new kind of a business process. So it imposes complements throughout the organization, because what it's talking about is working in a certain way. So when you work in a certain way, all of these functional ITs being powered by network ITs, be shared by that, gives you greater advantage than they would if you were doing them separately. Imagine if one department is using Excel sheets to do some work that they have to, but they're unable to share the data that they're generating on their Excel sheets with somebody that's working on a design for a new machine on AutoCAD or some similar software, and these people are unable to share data with another group of people whose job is to find who's probably looking at the quality management of their production and therefore are running different analysis using SPSS or similar software, then it becomes useless. So enterprise IT actually helps you do precisely that. So it also defines tasks and sequences, because that's the whole point. The enterprise IT is telling you that there are steps to an entire business process, to an entire value chain, and each one of these tasks and the step of these and the sequence of these tasks makes that entire enterprise and that business process work. Now, the use of this is mandatory, and it has its own strict data formats, because enterprise IT is meant to allow interoperability and integration within an organization. So you cannot allow everyone to have their own formats like you could in function IT. Say, for instance, if I'm using Microsoft Excel while somebody else is using Google Sheets, the format may be interoperable, but it's not the same. However, when you talk about enterprise IT, you have to make sure that it's the same format. So there are several examples given for enterprise IT software. ERP itself, obviously, CRM solutions, HRIS, supply chain management systems, financial management systems, all those systems that are basically integrated throughout an organization are referred to as enterprise IT. So there are lots of examples given in the document as well about the same. Now, there's a quote on page number 5, which you can see on the screen, which says, executives need to stop looking at IT projects as technology installations and start looking at them as periods of organizational change that they have a responsibility to manage. This theme was already covered in earlier articles by the same author, which is Andrew McPhee. We need to understand that IT projects are not about installing software. I mentioned the same thing when I'm talking about ERPs. They are always about the fact that these IT projects are here to make a change within the organization, within the psychology of the people working in the organization, within the way that the organization will now approach their business objectives and their vision itself. So you need to understand that whenever you are bringing in new technology, you are expecting your employees to change the way that they're thinking. You will expect your organization to change the way that they're trying to approach a problem. And that will require you to do what is referred to as change management. And if you don't do that right, your organization is going to fall flat on its face. Another aspect that I would add to this is never to think of technological implementations as a silver bullet. What do I mean by that? Silver bullets are, well, the idea comes from old mythological tales and stories of the supernatural, where silver bullets were used to kill werewolves, right? So technology is often considered by people as a one-stop solution to every problem that an organization is facing. If you do that, you're dead wrong. Technology doesn't solve anything. It is there to facilitate you to solve a problem. If you implement the technology thinking it will solve your problem, it won't. If you implement that technology while understanding and appreciating the fact that that technology is there to teach your employees how to deal with that problem, to leverage that technology so that they can actually solve that problem, whatever it is that they're facing. Maybe it's integration, maybe it's forecasting, maybe it's prediction, maybe it's handling customer problems. We've seen several cases with several different problems. But in every successful example, you will notice that that company understood that technology was a tool, not an end in itself, but rather a mechanism, or rather a factor to approaching that end. It was a means to the end, not an end in itself. Okay, so there are some examples given about a particular company, which is Ducati. I think that's a motorcycle company. So they said about different technologies. So now let's look at how different technologies help companies. So they gave examples in the 3 categories. In the first one, they said function IT. So they talked about how function IT includes several software like word processor like Microsoft Word, spreadsheets like Excel. So design engineers, accountants, doctors, graphic artists, all of them use functional IT. People get the most out of these technologies because of the complements that there are. For instance, a research and design engineer can use a CAD software, an AutoCAD like software, to make any changes that every other department can actually see. So functional IT doesn't bring any new complements with them. So CAD software, for example, doesn't specify the processes that make the most of its power. So it doesn't tell you how to use it, you have to choose it on its own. So they're given examples of that. So how did functional IT help Ducati, or how it can help any company? It can help by enhancing experimentation capacity. Because you have the tool available, you can make different stuff. So when you're writing an article, you can write it in different ways because you have the word processor. Number 2, it increases precision. So in the case of Ducati, that software that they were using to create the design of a motorcycle helped them improve their designs, make it more precise. Let's look at network IT. Network ITs, of course, allow people to communicate, and it allows them, people to experiment without telling them how to do it. So they can share whatever they're doing and collaborate with people. So they gave another example of DKW, which is apparently a company that's actually an investment bank, and they use this to share information with each other. So some examples of how it can be useful: it facilitates collaboration, I already said. So it also allows expression of judgment. So it helps you voice your opinions. So if you have a blog in your organization, and let's say an employee has an opinion about some new idea that's been implemented, or a new policy that's about to be implemented, then other employees can pitch in, and they can have a town hall meeting about it, they can have a meeting about it, discuss it. So collaborative softwares are very useful. In the case of most students who've gone through the COVID years, and some still are going through that, it was network IT software that let education and academia continue. Microsoft Teams and Google Meet, Zoom, all of these are network IT systems. they allowed us to continue to teach. YouTube, despite it being actually a platform for video sharing, was an extremely strong medium. The fact that you're listening to this video right now is an example of network IT technologies being useful. Then there's enterprise IT, and as I said, the entire idea is to integrate the whole organization and to help and support standardization. That's what it actually does. It standardizes the entire system. So the example that they're given is of another case study that we've discussed in the course, which is the CVS pharmacy case study. It discusses the same one of how an enterprise system helped them. So you can refer to the audio specifically for that to better understand this. So what does it do? ERP standardized workflows, and it helps you monitor activities and understand whether they're doing right or not. So in other words, to create a better value chain and to do business process re-engineering if required. So how do you manage these three types of ITs? That's what we have to look at next. That's on page number 6 of the article, as you can see. So the first thing that you need to do is IT selection. So companies need to select IT applications after they decide that they need one. So oftentimes they do it because somebody told them so. So they need to look at the fact that you don't just choose a technology because you were told so. Okay? You shouldn't be doing it because some technology sales guy told you so. You should do it because whether you need it or not. So there are lots of softwares available out there. You don't just go out and buy all of them. So the sensible question that the IT people should ask, or rather the business executive should ask, is why do we need IT and what do we need this IT to do for us? If the answer to that makes any sense, only then you decide to acquire that particular technology. So for instance, if you want to decide whether your company's engineers need some kind of new software to do experimentation, only then you should get that software. Do our salespeople need some software for forecasting? Only then you should get that system. Do you need to standardize a certain process? Only then you should get that system. So IT selection should be done based on your requirements. Otherwise, getting it would be pointless and useless. Okay, so where functional IT actually helps you do your productivity and optimization, network IT increases collaboration, and enterprise IT is for standardizing and monitoring. So they've also talked about enterprise IT at Cisco, which is another case study which you can also listen to, which covers the same thing. So there's a IT dialogue portion in the case on page number 7, which also summarizes the entire discussion. Let's review that too. Business and IT leaders should periodically meet to discuss what the company is doing right now and what IT technologies it has. And during these meetings, the CIO, the Chief Information Officer's role is not to come up with new technologies, but to discuss with their executives about how they can make better use of what they have and what they need. The discussion should cover organizational requirements, okay, and whether they need new technologies to continue with those. The expense required for those new technologies, the difficulty and time involved in deploying IT, especially enterprise IT, as we need. They should be talking about this. So the conversation should be broken down into these questions, and there are some questions that they've posed. So whenever you as a business executive or even an IT manager are thinking about any of these technologies, you should ask yourself these questions. You should learn to ask these questions in these meetings. If you're talking about functional IT, you should be asking, will any of the new software on the market enable our engineers, scientists and analysts and other workers to do their jobs more efficiently? If it will make them efficient, then we think about it. Otherwise we don't. Are our functional technologies outdated? If so, what has changed? Don't just go and get the new version of Microsoft Word because it's new. Get it if you are unable to do something in your older version of Microsoft Word. Only then it makes sense. Look at network IT. How do our people collaborate? Do we know what technologies they're using? Do we have new ways of letting qualitative information flow in all parts of our organization, horizontally and vertically? Should we try and find a method of helping them send us back feedback? Do we need one? How do we know what our people are working on and what topics they're thinking about in order to follow up what they're working on? Then there are some questions for enterprise IT. How are current processes not supporting our business needs? Which ones need to be redesigned? Which ones need to be extended to our customer and suppliers, which is backward and forward integration? Are there best practices that should be part of our system? How do we do that? How do we change ourselves according to the new environment? Are there important business activities or events that we need to monitor within an organization and see if they're not doing it right and improve them? Are there some data that's unavailable to us that we need to have access to, or some people need to have access to? And what's the most recent period that we could easily analyze to see whether we're doing well? How many hours back can we analyze? How many months? How many years? How many weeks? All of those are questions when you're thinking about enterprise IT. So then the next step after IT selection is IT adoption. So after you've selected your IT, and there's a quote here which says, once a company's needs are clear, the technologies it requires will come into focus. So if you know your needs, you will know what you need. Once you decide on them, now you need to adopt them. So once you've decided on them, now you need to look at adoption. The hard work of putting technologies they've invested into productive use. So don't just think that just because you've chosen the right technologies, they will also be accepted by your people or adopted by your people. And that's what you need to learn. You need to see how they can truly be accepted. And that's where change management comes in. So there's an interesting dichotomy between executives' roles when it comes to network IT adoption. Because the use of such technologies is voluntary rather than mandatory, but in these days it is also mandatory, some users don't use them and they don't understand its use. They don't understand why collaborating is more important. So rather than less, they think that they will lose control of their work. So as a result, adoption isn't very difficult. So some people will use it because they realize its importance, others won't. But you will have to convince them. So once network technologies are properly established, their use takes off, and the challenges for managers to refrain from intervening too much. So when you talk about network IT, once the people understand its usage, they will use it more often. It's like the forbidden fruit. Once your employees understand its usefulness, they will continue to collaborate and use network technologies. On the other hand, functional IT and network IT, enterprise IT is hard for companies to adopt, and we've seen that in various cases, and we will see it in upcoming cases as well, that people are just not willing to change. They don't like enterprise IT technologies because they change the way that the company is working. They change the way that they were actually doing processes, and because they affect cross-functional areas. So employees want them to be modified according to their needs, while that cannot be done because we need to use the best practices. So it's very hard to actually convince them to do that, and that is the entire crux of change management. So the biggest mistake business leaders make is to underestimate the kind of resistance you will feel when you come with enterprise IT. People don't want to change. It's referred to as user inertia or employee inertia. So there are several examples that are given here, and there are several examples, especially of the pharmacy, the CVS pharmacy example that we've covered in the entire case. So IT adoption is difficult. It requires a lot of concentrated effort, and if you don't do it right, the entire thing could completely fall on its face. So all enterprise IT adoptions that have been studied and who have avoided failure and unsuccessful adoption have done something. They have decided that at the outset how key issues about configuration adoption will be handled. So they realize the kind of challenges they have and what they need to change beforehand. There's another quote here which says, the biggest mistake business leaders make is to underestimate resistance when they impose changes in the way that people work. So always remember that. People will resist. People don't want to change. It is inertia. Okay, that's a concept in physics, by the way. So lastly, it is about IT exploitation. So business leaders' third IT related responsibility is to extract maximum benefit from the technologies that are in place. Companies can best exploit functional IT by fine-tuning organizational needs and about how it can, everybody can work together and help out. And for network IT, they know that sharing and collaborating will automatically make their work better, right? It should become part of their key performance indicators. And enterprise IT, of course, can be exploited. It's easy, actually. It's often easier than the adoption part, because once it becomes adopted, once enterprise IT becomes adopted, it automatically becomes part of that organization's way of doing things. And the advantages automatically start showing up, provided that the adoption has been done completely and properly. So for any resource to have an impact on a company's competitive position, it must be valuable, rare. This is the last paragraph. It must be valuable, rare, inimitable, and non-substitutable. If you recall, this is the VRIN model that I talked about in the very beginning of the course. So in any case, when you talk about IT, all three categories will fail to meet that criteria, right? FIT and EIT are technologies that are not rare and they're highly imitable. However, people often forget that software doesn't do anything. It's about how those technologies are leveraged. So if you remember, it's not about the valuability or the rarity or the insubstitutability and the non-substitutability or even inimitability of these technologies. Rather, it's the organization part, the Vrio's O part, which is important for these technologies. If your organization is organized to make use of these technologies, to exploit them properly, only then can you truly make use of these technologies and actually improve. So that's the end of this reading.